Okay, today we have the topic of nested design. So far we have discussed CRD, RCBD, and Latinisca, and then CRD and RCBD with sampling effect, and with how to handle those model with missing values. Likewise, we have developed some separate kind of models. So today we are in the stage of nested design. So first you need to understand what mean by this nested term. Design by level of one factor nested with other factor. Examples including classrooms nested within schools. So you can identify the nested term with respect to this example. Classrooms nested within schools. So you can separate several schools. Then the classroom, the classification of classroom have nested into the inside of one school. So we can say classroom nested within schools. Then in the second example, villages nested within DS divisions. So you can consider about some DS divisions. So the villages inside of these DS divisions have been nested within those DS divisions. Then farmers nested within villages. So farmers for a village have nested inside of that village. So we can say farmers nested within villages. So you can use experimental design to evaluate this kind of situations also. So in the previous cases, you will remember what are the things. If you use blocks, that is common for our whole case. But when we are having nested things, we cannot match or we cannot continue the homogeneous situation instead of these all villages or schools or these divisions. Let's see how to handle that kind of situation. Yeah. Then example 1, compare 4 district hospital waste. So we can handle this kind of question for the nested design. Then the factor is district. How many districts we have? We have 4 districts. And what's the condition we are considering? Hospitals. B. Then the hospital have been nested inside of the district. Then the replications are daily waste. The example 2, compare paddy yield eggs in district. Then this is pronounced as the yield for egg in district. So our main factor is district, the second factor is village, and the replications are yield per egg. And the other example, thick study in classroom studies. Then A and B are crossed in these studies. So, sorry, it's a question, are A and B are crossed in these studies? No, it's no. Then nested design, we say B is nested in A. So those two are not going across. We have nested in A. In all cases, we have identified what mean by A and B. So in all cases, B have nested in A. When levels of B are unique to a given level of A, but these are unique. Nested designs can also be thought of as incomplete factorial designs, most treatment combination. So this is something like incomplete factorial design. Still, we did not discuss what meant by factorial, but I think I will continue you factorial designs also, because with the short time of period, I will unable to conduct it online. Anyway, I will upload it as a recorded lecture, because next 14th week we use for the presentation. 15th also I focus on discussion. Anyway, I will upload leisurely later the factorial design also. Then you can learn factorial design leisurely. Then nested design is somewhat different from that factorial case. Consider a company that purchases its raw material from 3 different suppliers. This is a practical case. The company wishes to determine if the purity of the raw material is same for each supplier. So They assume that the company wishes to determine the purity of raw materials is same for each supplier. Then how many suppliers they are considering? They are considering 3 suppliers. There are 4 batches of raw materials. When they are taking the raw materials, they are considering 4 batches available from each supplier. Then 4 materials are available in 3 suppliers. So the company consider about these 4 batches of materials with respect to these each supplier. And 3 samples are taken from each batch to measure their purity. So they have taken 3 samples. So then that case has figured out in this way. There are 3 suppliers in blue colored box. Then in green color box, you can see the batches, and you can see with respect to each column, the samples for each cases. Then how many cases you have considered? There are 12 cases. Then you can all together there are 36 observation in your case. So in the factorial design, then I will brief here what I mean by the factorial design. All levels of one factor crossed all levels of another factor. So the cross effect is available for the factorial cases. These two are coming together. All possible combinations are represented in here. If you can fill in the table with unique replication, it is factorial. So if you can complete a case like this, it is a case with respect to factorial. But in next step, you cannot fill it in this way because you have considered 3 suppliers. Then under that, 4 badges. So here the case is somewhat nested because you cannot align that for this kind of situation. In this example, strain type is nested within fertilizer. Fertilizer is often called group, strain, subgroup. So this is another case rather than to this one. This is for somewhat different example. This example is somewhat different. This is another example. The nested factor is always random. So the nested factor should be always random. So the strains are random here. Strains are subgroups, and the strains type is nested within fertilizer. So if we have figured out a graph, the nested model is coming in this way. So these two are not available under this one. That means there is no any cross effect. So the nested model you can easily identify by figuring out this kind of thing. Okay, then the whole model illustrated again in this way. So this is the variance group. The first group is the variance group. The second group is the variance about subgroup within a group. So this is the variance of grouping. Then you know under the experimental design, basically we are considering about the variance. So in the first stage, we are considering about the grouping variance. In the second state, we consider about the subgrouping variance within a group. Then we consider about the variance among all subgroups. Then we can construct our ANOVA table in this way. So groups, subgroups within groups, and among all subgroups, and the total and the error. So we to calculate the FS statistic and the degrees of freedom is in this way. A minus 1 with respect to the previous example. There are 3 categories for A. There were 2 categories for B. There were 2 replications. So here there are basically there were 3 groups. Under each one there are 2 subgroups. Under that one subgroup there are 2 replications. So A is equal 3, B is equal 2, and R is equal 2. Then subgroup degrees of freedom of groups are A minus 1. This one is there. Then subgroups degrees of freedom, A times B minus 1. B is 2, 2 minus 1 is 2. So, sorry, 2 minus 1 is 1. 1 times 3 is also 3. Here it's coming as 2. This is 3. And this is multiplication of A and B. That is 6. R minus 1. 1 minus 1 means 1. Then it is 6 according to this example. Okay. Then for example, then again I have come on to the previous case. 2x study was control, 4 sites per egg, each with 5 replicates. There is no link for any site on one area to any site on another area. Study area, there are 2 study areas. Then we can control, we can use one site as a control. I think you know the meaning of control. I think once we also discussed about that. So you can apply. The control concept for here also. Okay, then subsamples are not appearing in both sides. So S1 to S4 is here, S5 to S8 is here. So these subsamples have nested in A, these subsamples are nested in B. X mean the replications. I think now you identify the background of applying nested models. Number of sites, replications need not be equal with each sites. Analysis is carried out using nested ANOVA, not a two-way ANOVA. This is not a case with respect to two-way ANOVA or Latiniskia. This is for nested design. So you need to identify what are the basic features of nested design. The nested design allow us to test two things. One, difference between study and control. And the second thing is the variability of site within areas. If we fail to find a significant variability among the site within area, then a significant difference between areas would be suggest that there is an environmental effect. So we are talking here with respect to the yield of a example. That's why those two terms are coming. But generally, you should identify what are the advantage of these nested model. We can study the thing with respect to the control, and we can study the variability of those two areas. In other words, the variability is due to the difference between areas and not to variability among the sites. So these things are the advantages in this kind of situation. However, it is highly likely that we will find variability among the sites. So the major grouping, we can find the variability of our major groups. Even if it should be significant, however, we can still test to see whether the difference between the area is significantly larger than the variability among the site within area. So actually the variability of our first grouping is somewhat larger than the second grouping, even though we are discussing about the areas and sites with respect to this example. We need to identify the variability of our first grouping is somewhat higher than our variability in last group, second groups. So this is the model. I think I have already taught you with respect to each model, you need to identify the equation. So this is the way of writing model for this case. So indexes A, often called the major effect, main effect. Indexes B, then that is called the minor sub factor. You can use these terms, major factor or main factor, and minor factor or sub factor. These are the terms, common terms for these cases. K index is the replications. So I is for main factor, I times J is for the sub factor, and K is for the replications. So as in all cases, mu is representing the grand mean. Rho I, the difference between the ith level mean of major factor and the grand mean. Tau ij, the difference between jth level means of minor factor B nested within the ith level of factor A and the grand mean. So now you know what are the terms and what are the respective uh, terms for those things. Then you can apply these equations to have a result. So this is the case you're having values, and I have already introduced you what are the answers. Then you can try those leisurely. So as a summary, nested designs are very common in environmental monitoring because we cannot use the same environmental situation in all cases. So even though we are in the same place, the soil status also will be different. So this kind of case so good for study the environmental monitoring, because I think as I introduced you at the very early, the experimental design is so popular in the agriculture field. So most probably environmental monitoring is good for this kind of application. It is a refinement of the one-way ANOVA. All assumptions of ANOVA hold: normality, residual, constant variant, etc. Need to be careful about the proper ratio of the mean squares. Always use graphical method, box plot and normal plot as visual aid to aid analysis. Okay, these are the things I need to teach you. So I think I'm no need to waste more time to teach you how to explain to how to do this explanation in the Zoom session. I think you can try these things leisurely. Okay, let's see how to do that. Then these are the numbers I have given you to do. Then okay, then as we done at very early, here also you need to create a correction factor. So this is about the correction factor. Then other cases, it is somewhat different with the correction factor. Then, okay, I think it's better to try. Then you know how to take this one. Don't need to mention that one. Okay, then can anyone ask any question about these notations? Ith one. Ith means we use the ith notation for the factor A. Then here you have I. There I means M1, M2, M3. So I means you need to take all summation for this M1. So M1 all together. Then these are the about subgrouping. These are the observations. So you need to add these all together, and you need to add these all together. You need to add these all together, and take the square value of that one. That's the way of solving this part. Then j one, when you are considering, you need to take summation for each column, ith and jth value considering. Yeah. Then you can take the square value of that one to this case. Then yeah, I think those are the only things you need to consider. Hope to meet you again next day with answers. You can compare your answers with this one. Okay, try to solve this one. If you had any question, you can ask. Finally, you need to complete this ANOVA table. Then you can construct your hypothesis separately for these is each test statistic. Then the way of having test statistic also have given in here. Okay, with that example, you can continue this one, and this is the end of nested model. So you can ask any question about nested model next day. Okay, I will stop today lecture from here.